Okay, so we are going to be working through 5F today. So 5F is all about determining the rules for graphs of exponentials and logs. So this is for Unit 3 and 4 methods. So these are a couple of the basic rules that we are going to be looking at. Y is equal to a e to the power of x plus b, and y is equal to a log base e x plus b. Okay, so we are going to look at an exponential function as a rule of y equals a e to the power of x plus b, and we've been given 2 points that this graph has. And we're going to work on finding the values of a and b. So likewise, whenever we are solving to find a rule, we always use the basic form, and we put in the points we know and construct two equations. So exactly what we've done previously, nothing is going to change. We're doing exactly the same today. So that means I will construct my two equations. My first graph will have 0 and 7, so I just plot those in. So I've got my x is 0 and my y is 7. And the same thing with 2 and 13. I'm just going to put those 2 points in. Now this helps us with the first equation because we've got e to the power of 0. So e to the power of 0 is anything to the power of 0 will just be 1. So then I've got 1 times a, and it becomes a plus b equals 7. Just because we will be using simultaneous equations eventually, I'm just going to take one of the variables to the other side to get a by itself. The next step is we are going to use simultaneous equations. So wherever I see a, I'm just going to plug it into this equation. So that means I've got 13 is equal to e to the power of 2 times 7 take away b plus b. The next step is I'm just going to expand. That means everything here will be timesing by e squared. Now, because I'm just wanting to find b, I want b to be by itself. So be mindful of that. I accidentally just wrote the same step again, so I just put it there. So that means I'm just going to take 7e squared to the other side. So now I've done that, over on my right-hand side, both terms have b, so straight away I could just factor that b out. So if I factor that b out, I've got b in brackets negative e squared plus 1. So to get b by itself, I just need to divide everything by negative e squared plus 1. So now I know my b value. Now we know our a value of 7 take away b, so I can just substitute that into that equation and I'll get 7 take away this. Okay, so now I have this. And then that can be simplified to a is equal to 7e squared minus 13 over e squared minus 1. Okay, so now I'm just going to plug in those two values into my equation. Let's move on. A logarithmic function has a rule y equals a log base e x plus b, and again we're given 2 points. So it's the same process. We are just going to use those 2 points to construct two equations. So with our basic graph, I'm just going to plug in y is 0 and plug in 4, and I'll plug in y is 3 and x is 9. That's the first thing that we'll do. The second thing I'm not looking at, because it is equal to 0, we're going to think of the equation of products. That means a times log e 4 plus b would equal 0. So one of them has to be 0. So that means if we say a is not going to be equal to 0, then log base e4 plus b has to. So that allows us to just get b. And so then I can use my relationship here by changing it from log to exponential and say e to the power of 0 is equal to 4 plus b. We know anything to the power of 0 is 1. So to get b by itself, I'm literally just going to go 1 take away 4, which gives me -3. Now I've got that, I can just substitute that value into my equation. So that means I'll use this equation here. 3 is equal to a log base e, 9 plus b, and I'll plug in -3. 9 take away 3 is 6. So again, log e I can write as ln. So my log base e 6, I'm going to get rid of to get a by itself by dividing. So that gives me my a value is 3 over log base e6. So every single time the skill is not changing. Okay, this question here we've got an exponential function has a rule y equals ae to the power of kx plus b. The graph passes through 0, 4, and 1 and 10 and has a horizontal asymptote y equals 2. Find a and k. So the first thing I'm going to take off b, because b is the part that gives us this asymptote. Or sorry, helps us see it. So for us to identify the b, I'm going to use the asymptote of y equals 2, and that tells me what my b is going to be. Likewise, in the last couple of questions we've done, it goes back to doing exactly the same. We've got 2 points, we construct 2 equations. So I'll use 4 and 0, and then I'm going to use my next equation in a minute. But first, 0 times k is just 0. A to the power of 0 is 1, so a must be 2. With the second equation, I've got 10 is equal to ae to the power of k plus 2. I'll get 2 to the other side by taking it away. And now I can just substitute that value for a into this question. And all I'm left with is k. So I can divide both sides by 2, and that gets me 4 is equal to e to the power of k. Using e, I can write it as log, so k is equal to ln 4. If I wanted to write it as an equation, I can just say it's 2, y equals to e to the power of ln 4, x plus 2.